In this question, we're thinking about nitrogen and bromine, which both form diatomic molecules. And we have images showing what they look like. So we can see that the nitrogen N2 molecule is shown with smaller atoms, since nitrogen has a smaller atomic radius than bromine, whereas bromine is shown with bigger atoms since it has a larger atomic radius. Nitrogen also forms a triple bond, so we can see we've got those 3 lines between our atoms, whereas bromine forms a single bond, so we've only got 1 line between our atoms. Okay, so it's first asking which element has a bigger atomic radius. So looking at our diagrams, bromine has a much bigger atomic radius. What about the bond order? We've seen nitrogen has a triple bond, bromine has a single bond. So nitrogen contains a higher order bond. Now we need to use that to figure out the length and the energy. So we need to remember for the bond length, there are 2 things. As the atomic radius increases, the bond length is also going to increase. Then also, as the bond order increases, the bond length is actually going to decrease because a stronger bond holds the atoms closer together. So to find the one with the greatest bond length, we want the one that has a greater atomic radius but a smaller bond order. The one with the greater atomic radius is bromine. So bromine is going to have the greater bond length. Then it asks about bond energy. The bond energy is going to be most related to our bond order. So as our bond order increases, our bond energy is also going to increase. So which molecule has a higher bond energy? The one with a higher bond order, which is nitrogen. Okay. So now we're told that our graph has that dark blue line representing nitrogen. So let's just make sure we've seen that on our graph. This line here, this dark blue line, that represents nitrogen. And we can see we've got internuclear distance on the x-axis and potential energy on the y-axis. So there are 2 things to take note of here. One is the internuclear distance, which is on this axis. So that's the distance between our nucleuses of our 2 elements. The other thing is the potential energy, which is shown here on the y-axis. So we need to figure out which of the dotted lines represents bromine if that dark blue line represents nitrogen. So first let's look at the bond length. So we know that bromine has a greater bond length than nitrogen. So nitrogen's bond length is measured here on our graph. The bond length is the position of that peak there on our graph. So if bromine has a greater bond length, we're expecting the peak to be moved this way. So we would think the peak would be somewhere over here. So that's making me think it's either going to be 2 or 4 as our options, since they have the peak further to the right, showing a greater internuclear distance and a greater bond length. What about the energy? So we know that nitrogen has a higher bond energy. So nitrogen should have a higher or a greater peak than bromine. So we're expecting the peak on the graph we're looking at to be smaller than the peak of the dark blue main line. However, notice the way that it's labeled on the graph. Potential energy has an axis running through there. So that's our 0 potential energy. And underneath, these are actually showing negative potential energies. So we're looking for the greatest value for the bond energy. And since these are negative numbers, this value at this point is greater than the value at this point. So number 2 has a smaller bond energy than nitrogen, and it has a greater internuclear distance, a greater bond length. So number 2 is going to be the dotted line that represents the graph for bromine. So the two things we're looking at here are our bond length. If it has a greater bond length, it's going to be shifted to the right. On the other hand, if it has a smaller bond length, it's going to be shifted to the left. Then we have the bond energy. If it has a greater bond energy, it's going to come down lower on the graph. That's going to be to a greater value of energy. On the other hand, if it has a smaller bond energy, then the peak of the graph is going to end up in a higher location on the graph, showing a lower value for our potential energy and therefore a lower bond energy.